Hey everyone, this is Big Face from Big Face Robotics. In my last video in the RC Robot series, you saw me design, build and test a 3D printed worm drive gearbox with good results. The plan being to rebuild the RC Robot using these gearboxes instead of the spare gear design I was using previously. So I've pretty much rebuilt the robot from scratch. I've reused a handful of components. So here you can see it sitting out in the sunshine completed. So the main aim was to slow the robot down slightly. The worm drive gearboxes are about a 7:1 gear ratio now instead of what I had before, which was around a 3:1. So the wheels are now a lot slower, but I've got plenty more torque and the robot's much easier to control. I also think this redesign makes the robot look a lot nicer as well. So at this stage, all of the components sit beneath the top plate of the robot, again making the robot look a bit cleaner and neater. So removing the top plate, you can see the changes from the first design. The batteries have been rotated 90 degrees and sit nicely on the base plate, and you can see the two aluminium angle sections that run the length of the base plate. These not only form a nice place for the batteries to sit, but I can mount other components onto these, just like the rear caster assembly, which we'll look at again in a second. A closer look shows the worm drive gearboxes mounted to the base plate. These are still running well. I haven't got a lot of hours on them, maybe only half an hour, maybe to an hour of run time, but they're still looking as they did when I built them. And you can see a bit of lubrication on the gears there. That seems to help quieten them down a bit and make them run smoother. So I've rebuilt the Arduino Nano based control board. This is about a quarter of the size of the previous circuit, and now fits nicely on the base plate next to the motor driver. I 3D printed a bracket which slots over the aluminium angle sections and holds both boards securely. I've also printed a power switch bracket, and the power rail sits on top of this as well, which neatens all the wiring. And here's another look at the rear caster assembly. As you can see, it's mounted to the aluminium angle sections along with the newly printed top plate supports. If we look at the gearboxes again, you can see I've got an encoder, the same design as previously, but I've rebuilt the encoder circuit, made it a lot smaller, and 3D printed some nicer looking brackets that attach directly to the gearbox. So this gives a nice complete unit of the drive and the encoders. So while the sun was still shining, I took the robot for a test drive. It's performing well. The control is a lot easier now, it's a bit slower. Very accurate control of speed and turning. And obviously by slowing the wheels down a bit and increasing the torque, the transition from the paving stones to the grass in this clip, the robot doesn't lose any speed and plenty of power to drive around in the garden. So I've always intended to automate this robot. I know I've called it the RC Robot, but it will be autonomous to some degree in the future. The first job's going to be to add some machine vision in the form of a Raspberry Pi with a webcam, so that'll be in the next video, so keep an eye out for that. So at this stage I'll probably just be capturing some video and then doing some processing it offline from the robot, and look at how I can automate the robot to drive around my back garden. So while the robot's happily driving around in the sunshine, I'll say goodbye. Please consider subscribing to my channel and liking this video. I do appreciate it. And as always, thanks for watching.